Hello, student. So, in this lecture, we will study about registers. Okay. So, our topic is register. Register. Okay. Uh, Actually, we are learning about digital registers. Okay. Okay. We are learning about. We will learn about digital registers. Okay. Uh, so you already know that register is a digital device. Okay, it is a digital device. Okay, so register is a digital device. We already know that it is used to store data. Okay, store data. And there are many type of registers available in the market. Okay, for different purposes. Okay, so uh, now today we will focus on shift registers. Okay, what is called shift register. Okay, um, so this is one type of register. Okay, widely used for many application. Okay, in with digital processing, signal processing, we use this kind of registers for encoder, decoder, like that. Okay, uh, so so the basic building blocks. Okay, so the basic building blocks of the registers, okay, of any registers, okay, as well as shift register, okay, are flip-flops. Okay, you already know that flip-flops. Okay, uh, uh, actually, there are many uh, logics, the shift registers available in the market. Okay, uh, so I hope, okay, I believe that most of shift registers available in the market, okay, available in the market consist of SR flip-flops, okay, SR flip-flops. Uh, Actually, basic building blocks is we can say that, especially we can say D flip-flops, okay, D flip-flops, okay. But as I know, okay, maybe it is not 100% correct, okay. As I know, many flip-flops available in the market as SR flip-flops, but we can configure this SR. You already know that, no? We can configure this SR flip-flops as a D flip-flops, okay. So in the market, I hope many uh, uh, shift registers consist with SR flip-flops. Okay, it may be not correct 100%. Okay, I don't know exactly, but I believe that. Okay, uh, okay. So another thing is that uh, there are several type of shift registers available. Okay, there are several type of shift register available. Shift register available. Okay, actually those are classified. Okay, those are classified based on the um, uh, the read and write uh, process. Okay, based on the read and write process of the flip-flops. Okay, read to the flip-flops and write, read from the flip-flops and write to the flip-flops, not flip-flops, register. Okay. So this classification mostly based on the input and output output how to say output technique. Okay. So some register has serial input. Some register has serial input. Okay. We input the data serially. Okay. To the shift register. Okay. So if the shift register is like that, okay, we input data one by one, serial. Okay. So first we send this data, then we send this data, so on. Okay. So that is the serial communication. No? You already know, you may know that because you are mechatronics students. No. Okay. But anyway, this is called serial communication. We send the data one after one. Okay. So that is the serial communication. Okay. And the input to the flip-flops are serial. Okay. So we have serial input and the output also serial. Okay. So output also we get one by one like this. Okay. 0, 1, 0, 1, so on. Okay. Okay. So we have a serial input and also we have a serial output. Okay. So that is one type. Okay. Serial input, serial output. Okay. So that is one type. Okay. And sometimes we have for different purposes, sometimes we have to use, we have the serial input, we have a serial input, but we have parallel output. Parallel output. Parallel communication means the block of a data communicate at once. Okay. So the flip-flops is like this. Okay. So as in the previous way, okay, we have serially input the data. Okay. Serially input the data. That means only one communication line. Okay. Only one port should be there. Okay. Because we send data one by one. Okay. So only one port is enough for the input. Okay. But output is not serial. Output is parallel. Okay. So we have to get several data at once. Okay. Several data at once. Okay. So this is serial input to parallel output. Okay. So this is serial input, parallel output. Okay. And also we have the vice versa also. Okay. We have, sometimes we have parallel input, and the output is serial. Okay. So serial output. Okay. So we have parallel input. So we give several input bits at once. Okay. And but the output we get one by one. Okay. So this is parallel input, serial output. And the other type is we also input the data parallelly and we get the data parallel. Okay. So that is parallel output, parallel input, and parallel output. Okay. So these four classifications are available in shift registers. Okay. These are based on the way it has input and output. No? Okay. So it is based on the input and output way. Okay. So we have CISO, CISO, PISO, PISO. Okay. So these four types we have in the market, shift registers. Okay. Okay. So I will get one example to show you how a shift register is working. Okay. So I will get one example. Okay. I have one, actually we have one CISO, okay, serial input, serial output shift register. Sorry, yeah, shift register in our lab, okay, in our lab, okay. So that is, I have write it 7491, okay, 7491. Shift register, okay. So this is a shift register. So the IC number is IC 7495. Okay, so this is serial input, serial output register, shift register available in our labs, electronics labs. Okay, and and so it is 8-bit 8-bit shift register. Okay, it is 8-bit shift register. Okay. So I think if you go to the, I think you can search this in the internet and you can get the data sheet and you can refer more. Okay. So anyway, so this IC is made of with 8 flip-flops. Okay. So this IC 7491, this shift register IC is made of with 8 SR flip-flops, okay, SR flip-flops, and they are, as I can remember, they are negative edge triggered flip-flops, okay, negative edge triggered flip-flops, okay. So anyway, we will see how this flip-flops is working, okay, how this shift register is working. Actually, that names comes from that it is shifting the bit, okay. For example, let's say that we have a 8-bit register like this, okay. So this is 7, 6, 5, 4, 3, 2, 1, 0, okay. So these are memory location, 1-bit memory location, okay, 1-bit memory location, okay. So we have 8 such memory location, okay. So this register can store 8 bits, okay. So this register can store 8 bit, okay. So this is let's say that the bits are input serially, okay. Let's say that the bit are input serially, okay. So let's say that initially it has 0, 0, 0, 0, 0, 0, 0, 0 like that, okay. So let's say that first we input, okay. So this is the initial condition, okay. We have all the memory location have 0 bit, okay, okay, at the initial, okay. So let's say that if we want to send 1, okay, if we want to send 1 to this register, shift register, okay. So it is happening like this, okay. So this 1 will push to this register, okay. So now, okay, now the register will be 1 here, okay, and this 0 is shifting to here, okay, next level, okay, next memory location. So this will be 0 and this 0 will be shifted to here, okay, and again this one 0 and this 0 will be shifted to here. So it will be 0 again, and this is shifted 0, this is shifted 0, this will be shifted 0, this will be shifted 0, Okay. Now let's say that again you push 1. Okay. Okay. So let's say that you are sending 1, 1, 1, 0, 0, 1, 1 bit stream. Okay. You are going to send this. Okay. So first you send 1. Okay. Then you send again 1. Then what happened? Okay. So this one is come to this location. So it will be 1. Okay. And it will be 1. Okay. So this location now, the bit will be 1. And here it is 1. No. So it is shifted to here. So it will be 1. Here it is 0. It is shifted to here. Again, it will be 0. This is 0. No. This is shifted to here. So it will be 0. This is shifted to here. It is 0. This is shifted to here. 0, 0, 0. Like that. Okay. So again, 1 is sent in. Okay. So if again 1 send, okay, what happened? This is shifted to this one. No. So this will be 1. And this one is shifted to here. So it is again 1. And this one shifted to here. So here again 1. And this is shifted to here. This 0 shifted to here. This 0 shifted to here. So you will have 0, 0, 0 like. Okay. Then again you have to send 0. Okay. So now you are pushing 0 here. Okay. Then what happened? This 0 come to this location. So it will be 0. And this 1 is shifted to next one. So it will be 1. And this one will be shifted to next memory location. So it will be 1. And this one will be shifted to next memory location. So it will be 1. And this 0 is shifting to other memory location. So this will be 0. This is again shifting. So it is 0. This is shifting 0. And this is shifting 0. Okay. So again you are sending 0. No. The next bit is 0 again. Okay. So what happened? This 0 is shifted to here. Sorry, this 0 is shifted to here. So here you have 0. And now this 0 is shifted to here. So it will be 0. This 1 is shifted to here. So it is 1. This one is shifted to here. So it will be 1. And this one is shifted to here. It will be 1. And this 0 is shifted to here. 0. This shifted to here. 0. This shifted to here. 0. Okay. Again, you are sending 1. Okay. You are pushing 1. Okay. So this 1 is shifted to here. So it will be 1. This 0 is shifted to here. It will be 0. This 0 is shifted to here. So it is 0. This 1 is shifted to here. 1. This one is shifted to here. And this one also shifted to here. This 0 is shifted to here. This 0 is shifted to here. 0. Okay. 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 So this is that one. Okay. Again, 1 shifting. Okay. So again, what happened? This one is now again you push 1 to this location. Okay. Then this is shifted to this location. So it will be 1. And this one will be shifted to this location. 1. This 0 is shifted to this location. 0. This 0 is shifted to this location. 0. This 1 is shifted to this location. 1. And this one is shifted to this location. 1. This one is shifted 1. This one is shifted 0. Okay. So that is why it is named as shift register. Because when we push a bit, it is shifting. It is shifting to this way. Okay. So that is why it is called shift register. I hope you could understand the concept. Okay. It is shifting. So when you are sending bit stream like this, okay. Okay. So we have shift registers. Okay. We have some memory location with the register. Okay. So when this comes to this one, the value here is shifted to this memory location. Then the value here will be shifted to this memory location. The value here will be shifted to this memory location. Likewise, the previous value is shifted to next memory location. Okay. So it is shifting. Okay. So that is why it called shift register. Okay. Okay. So now we will see. Okay. Now we will see the architecture of this 74991 register. Okay, so it will look like this. Okay, so it will look like this. Okay, so here, okay, I will draw it here. Okay, so first we have A and B. Okay, and it is sent through a NAND gate. Okay, then we have a NOT gate inverter. Then this NOT gate is connected to a SR flip-flops. Okay, SR flip-flops, and the output here is connected to the other input. Okay, so this is S and this is R. Okay, and this is Q and this is Q bar. Okay, now we have 8 such flip-flops. Okay, we have 8 such flip-flops like this. Okay, like this up to 8. Okay, so we have 8 such flip-flops. Okay, like this. Okay, so this is first flip-flops, this is second, third, fourth, 5, 6, 7, 8. We have 8 flip-flops. Okay, okay, so to see the operation, okay, we just consider only 4 flip-flops. Okay, so we just consider only 4 flip-flops. Okay, okay, 4, because we are trying to understand the operation. Okay, we are trying to understand the operation of the flip-flops. Okay, so just take only 4 flip-flops. Okay, then the same way you can do it for 8 flip-flops also. Okay, so so this is, let's say that this is S1 R1 first flip-flops. This is S2 R2. Let's say that this is Q1 bar, Q1 and Q1 bar. Okay, and this is S3 R3 Q. This is Q2 and this is Q2 bar. This is Q3 and this is Q3 bar. Let's say that this is S4 R4. Okay, and this is Q4 bar. Okay, Q4 bar. Okay, so we have these 4 shift registers. Okay, okay, so here Q1, this one is Q2, this one is Q3, and this one is Q4. Okay, okay, so I think if you consider this one, okay, if you consider this one, what is this? Actually, this is a D flip-flops, no? Okay, so this is a D flip-flops. Okay, please try to refresh your memory on this. Okay, so this is a D flip-flops actually. Okay, okay, and there should be a clock. Okay, I can't remember exactly this is a negative edge trigger or positive edge trigger, but it will not affect to the operation. Okay, whether it is negative edge triggered or positive edge triggered. Okay, the transition happen at the any edge, that is okay. Okay, so this is the clock. Okay, and we have a clock also. Okay, so the clock should be given parallelly. Okay, so all the clock should be given parallelly like this. Okay, and this will be the clock pulse. Okay, so this is actually 4-bit. See, so shift register, we will see how this operate. Okay, so let's take that same bit stream. Okay, so I will take this same bit stream. Okay, this one 1 1 1 0 0 1 1. Okay, Okay. So let's say that we are sending 1 1 1 0 0 1 1. Okay. 1 1 1 0 0 1 1. Okay. So now let's say that initially all this location has 0 0 0. Okay. All this location has 0 0 0. Okay. Then okay. So we need to find the bits at Q1, Q2, Q3, Q4, Q5, sorry, Q4, okay, Q4 up to Q4, okay, and also we need the available bit at S1R1, S2R2, S3R3, S4R4, okay, and we need this bit stream also, okay. So, okay, we will see what happened, okay. So, you can input from A or B, no issue. You can input from A or B, okay. But the input, any input pin you can select it, okay, as the input pin, and other should be set to 1, always set to 1, okay. So I select A pin as the input pin, so that I select, okay, I set this B to 1, okay, set this B to 1, okay. Now, initially, let's say that we have 0, 0, 0, 0, okay, and let's see what are the value at S1 and R1, okay. So let's say that initially here A also 0. Now B is set to 1, okay, B is set to 1, okay. So 0, 1, that means 1, okay, that means 0, and it is again converted, no, so here it is 1, no, okay, because this is an AND gate, okay. So here we have 1, okay. So S1 is 0, and because again 1 converted to 0 again, no, okay. So S1 is 1, S1 is 0, R1 is 1, okay. So S1 is 0, R1 is 1, okay. I think it is easy to understand, okay. And you can see that Q1 is 0, Q1 is 0. So Q1 bar should be 1, no? Q1 is 0, so here it is 0, so this should be 1, okay. So S2 is connected to Q1, so this will be, S2 will be 0, and R2 connected to Q1 bar, so it should be 1, okay. So this should be 0, 1, okay. In the same manner, Q2 is 0, so S3 is 0, Q2 bar is 1, so R3 is 1, okay. So we have 0, 1. In the same manner, we have S4, 0, and R4, okay. This is R4, this is R4, it is again 0, okay. So this is the initial condition, okay. So this is the initial condition, okay. Now, let's say that we want to input A, input 1, okay. So the first input is 1, okay. So the first input will be 1, okay. And if it is set to 1, what happened, okay. So if it is set to 1, you can see that this is 1 and B is 1. So output of the AND gate is 1, so it is NAND, and it will be 0. So this will be 0, and it is convert again to, the 0 is converting again, because here it is a NOT gate, okay. Here we have a NOT gate, okay. So again, this will be 1, okay. So you can say that, you can see that if input, if A is 1, R1 will be 1, and S1 will, sorry, R1 will be 0 and S1 will be 1. Okay. 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 So let's say that that is set like this. Okay. That is set like this. Okay. So now if you consider the value, okay, if you consider the value, if you set 1 here, okay, if you set 1 here, S1 will become 1, R1 will become 0. It is clear now, because here you have 1, 1. So output of the NAND gate is 0. So it is connected to R1. Okay, so R1 will be 0 and S1 will be 1. Okay, because here you have a NOT gate. So 0 is converted into 1 again. Okay, so you have 1 again here. Okay, and these flip-flops are same, no? There are no any change to these flip-flops. Okay, so it will be 0, 1, 0, 1. Okay, because this one also 1. Okay, so now we have this input status. Okay, let's say that now we have a clock pulse. Okay, so it may be a negative clock trigger or positive edge trigger. Okay. Okay. So you can see that if this rising edge or falling edge, you will have a transition. Okay. Let's say that the clock pulse is available. Now we have the transition. Okay. Okay. So before that, you need to have the function table of the SR. Okay. SR flip-flops. Okay. So I will write it here. Okay. Shall I write it here? Okay. So I will write here the function table. Okay. So it is like this. Okay. We have S and R and we have Q in plus 1. No? Okay. So we have 0, 0, 0, 1, 1, 0, 1, 1. Okay. So what are the Q n plus value? Okay. So I write it here somewhere. I can't remember actually. Yeah, I got it. Okay. I got it. Okay. So if SR, if S0 and R0, you have the Qn. If S0 and R1, you have 0. If S0, 1 and R0, you have 0, sorry, you have 1 again. 1, 1, that is not valid. No. Okay. So this is the function table for, this is the function table for the SR flip-flops. Okay. SR flip-flops. Okay. 0, 0 Qn, 0, 1, 0, 1, 0, 1, 0, 1, and 1, 1 is 0. Okay. So this is the function table for SR flip-flops. Okay. Okay. Don't worry, you no need to remember this. Okay. I will give this to the exam paper. Okay. But if you can remember it. Okay. It is easy for your study. Okay. So already you know that this is reset mode. This is reset mode. And this is set mode. Okay. 1, 0, 1, 0, 1, 0, 1, 0. Actually, we need only these two conditions. Okay. Set and reset. Okay. You can see it. Only this S and R toggled between these two conditions, reset or set. Okay. So you can see that initially it is in set mode. No. S1 R0. Oh, sorry. sorry, S0 R1. So it is reset mode. It's 0 R1. Okay, that is the initial status of all flip-flops. Okay, so all flip-flops are in reset mode. Okay, so Qn should be 0. Okay, so Qn should be 0. At that time, all bits are 0. Okay, okay, now what happened? Now we set 1 here, 1 here. Okay, then S and R will change like this. Okay, what happened if the clock pulse available? Okay, so the transition happened, no? So you can see that now S1 R1 is 1 0. Okay, S1 R1 is 1 0. So that is set condition. Okay, so S1 is 1, R1 is 0. So that is set condition. Okay, so this first flip-flops, this flip-flops now has the set condition. S is 1, R is 0, S1 is 1, R1 is 0. So it is set condition. Okay. So Q1, the output of that flip-flops will change to 1. Okay. Will change to 1. Okay. And other will not change. Okay. Let's see that. Okay. Okay. Now you can see that the other will not change because other has set reset condition, no? 0 1 0 1 0 1. So others are not set. Others are not set. It is in again 0 reset condition. Okay, so Q1 will be changed to 1, but Q2, Q3, Q4 stay at reset condition. Okay, so this will be 0 0 0. Correct? Okay, I hope you can understand this. Okay. Okay. Now, what are the SNR flip-flop? SNR is status. Okay. Let's say that the next bit is 1. Okay. Now the next bit is 1. Okay. Now we have next bit, that is 1 again. Okay. So here you have 0 again, and S1 you have 1 again. Okay. So S1 you have 1 again. R1 you have 0 again. Okay. And what about S2 and R2? What is the value at S2 now and R2? So you can see that S2 is connected to Q1. Okay. So what is the value at Q1? It is 1. Okay. So now S2 is also 1. S2 also will become 1. And S2 is 1. Okay. So Q1 is 1, Q1 bar should be 0. So R2 will be 0. No? Okay. And these are not changed because Q2 is 0, Q2 bar is 1. Okay. So you have 0, 1. And here also Q3 is 0, Q3 bar is 0. So you have 0, 1 again. Okay. Okay. So now you have S and R in this condition. Let's say that now again, the clock pulse is available. What happened? This status will be changed. Okay, so what happened? Okay, so you can see that S1 and R1 has 1 0. 1 0 means set condition. So Q1 will be 1. Okay, and what about S2 R2? So you can see that it is also 1 and 0. It is also in set condition. Okay, 1 and 0. So Q2 is also will be 1. Okay. What about Q3? Q3 is 0 1. Sorry, 0 1. So that means it is reset mode. So it will be 0. Q4 also in reset mode. So it will be also 0. Okay. So now the values are 1 1 0 0. So what happened? At the second clock pulse, at the second input, what happened? So you can see that this 1 is shifted to here, and the input 1 is shifted to here. So you have one input and it is shifted to Q1. Okay. So 1 is here, and this one is shifted to here. So here 1, and this 0 is shifted to here. So you have 0. This 0 is shifted to here. You have 0. Okay. So you can see that it is shifting. No, it is shifting. Okay, let's see. Okay. Again, what happened? Now again you have 1. Okay. Now you have to push 1 again. Okay. So what about the SR status? Okay. So if it is 1, okay, if it is 1, this will be 1 and this will be 1. So output of the NAND gate will be 0. And again it is converting, so it is 1 again. So okay, so S1 will be 1 and R1 will be 0. Okay. So the next condition, next SR here is S1 will be 0, R1 will be 0. S1 will be 1, R1 will be 0. Okay. And what about S2? S2 is connected to a Q1, no? Okay, so what is the value at Q1? That is 1. Okay, then S2 will be 1 and R2 will be 0 because it is bar, Q2 bar, Q1 bar. It will be 0. Okay, and what about S3? Try to fill it by yourself. What is the value of S3? Okay, so it is the value of Q2, no? Now Q2 is 1. Okay, so S3 will be 1 and R3 will be 0. And what about S4? Now Q3 is 0. Okay, that means S3 is 0 and R4 will be 1. Okay, so these are the input stated for each flip-flops. Okay, let's say that again the clock available. What happened? So again it changed the status. No, all the flip-flops will change the status based on the input. Okay, so you can say that at the first flip-flops we have 1 0, that is the set mode. So you have 1 here, and the second flip-flops also you have set mode 1 0, so it's set 1 again. And the third flip-flops also you have 1 0, so that is set condition. Okay, so you have 1 again, and at the fourth flip-flops, you have 0 1. That means that is reset mode, 0 and 1. Okay, so you have 0 here. Okay, so you can see that now what happened. Now you have pushed 1 here again. What happened? That's 1 is pushed to this one, Q1, so it is 1. And this one is shifted to Q2, it is 1. Q2 is shifted to this one, so it is again 1. And this 0 is shifted to Q4. So you have 0. So you can see that again shifted, no? Again, all bits are shifted to this way. Okay. Okay. Now let's see the next bit. Okay. Next bit is 0. Next bit is 0. Okay. What happened if the 0 available? Okay. So you can see that now A is 0 and this is 1. Okay. So output will be 1 here. Output will be 1 here. And when it inverted, it is 0 here. Okay. Now you have S1 0 and R1 1. Okay. So now you have S1 0 R1 1. Okay. So you have 0 1. Okay. And what about S2? S2 is connected to Q1, this one. So Q1 is 1. So S2 should be 1 and R2 should be 0. Okay. And what about S3? S3 is connected to Q2. S3 is connected to Q2. Q2 is 1. Okay. So you have 1 here. S3 is 1 and R3 is 0. And what about S4? What about S4? S4 is connected to Q3. What is the Q3 value? 1. Okay. So now S4 also will be 1. That means R4 will be 0 because it is connected to the Q3 bar. Okay, this is connected to the Q3 bar. So it will be 1 and 0. Okay, so now let's say that again the clock transition happened. Okay, then what are the value here? Okay, so you can see that now S1 0 and R1 1. Okay, so now S1 0 and R1 1. That is reset mode. That is reset mode. So Q1 will be reset. It will be 0. Okay. What about Q2? It is 1 and 0. That is set mode. So Q2 will set to 1. What about S3, R3? It is again set mode. So you have 1 again. And what about this one? So you have 1, 0 again. So it is set mode. Here, what happened? So now you are pushing 0 here. So this 0 is shifted to here at Q1. Now Q1 is 0 and this 1 is shifted to Q2. It is 1. This one is shifted to Q3. It is 1. And this one is shifted to Q4. It is 1. Okay. So that is happened. Okay. Let's say that again you have 0 here. Okay. Again you have 0 here. So you have 0 and 1 and then you have 1 here and you have 0 here. Okay. So what are the S and R value here? So S1 is 0, R1 is 1. Okay. So you have 0, 1. Okay. And what about S2 and R2? S2 is connected to Q1. S2 is connected to Q1. So Q1 now is 0. Okay. So it will be 0 now. And R2 will be 1. Okay. And S3 is connected to Q2. S3, you can see that S3 is connected to Q2. Okay. Now S3 is connected to Q2. Q2 is 1. Okay. So S3 also will be 1. So that R3 will be 0. Now S4 connected to Q3. Q3 is 1. So S4 also 1 and R4 will be 0. Okay. Let's say that again the transition happened. Okay, clock transition happened. Now what happened? Now S1 0, S1 0 and R1 1. That is reset mode. Okay, that is reset mode. Okay, so you have 0 here. You have 0 here. Okay. And S2 is 0 and R2 is 1. That is again reset. Okay. So you have again at Q2 also you will have 0. Okay. S3, R3, 1, 1, 0. So it is set condition. So you have 1 here. Q4 is also 1, 0. So you have set here. Again, it will be 1. Okay. So what happened? Now you can see that you push 0 again. No? You push 0 again. You push 0 again. This one. Okay. So you are pushing 0. Okay. So you can see that this 0 is shifted to Q1. So it is 0. And this 0 is shifted to Q2. It will be 0. This one is shifted to Q3. It is 1. And this one is shifted to Q4. It will be 1. Again, this is shifting to this way. No? Okay. Okay. Then what is the next bit? That is 1. Okay. So what happened is the 1 is available here. So you can see that this is 1 and this is 1. So 1, 1, you will have 1 at the NAND input, at the AND input, but this is NAND. So 1, 1 will be 1 and it is converting and you will have 0 here. Okay. And 0 is converting again to 1. Okay. But now what is the value at S1? It will be 1. Okay. The value as at S1 is 1 and R1 will be 0. Okay. So what is the value at S2? S2 is connected to Q2. The Q2 value is 0. So S2 you have also 0 and R2 you have 1. What is the value at S3? S3 is connected to Q2. The Q2 value is 0 and here also you have 0 and R3 is 1. Okay. And what is the S4 value? S4 value is connected to Q3. Q3 is 1. Okay. So here you have 1. Okay. And R4 is 0. Okay. So you will have this input combination. Okay. So what happens if the clock pulse available? Okay. So you can see that now it is S1 is 1 and R1 is 1. So it is set condition 1, 0, set condition, this condition 1, 0. So this will be 1. Okay. So this will be 1. Okay. And S2 R2, it is in reset condition. Okay, so Q2 will be reset. It is 0. And S3 R3 also 0, 1. Okay, so again it is also set to, sorry, it is also reset 0 because it is 0, 1. And S4 R4 is 1 and 0, 1 and 0, 1 and 0. So it is set condition. So it is set to 1 here. Okay. So what happened? Now you push 1 here. Okay. So 1 is pushed to this location, and this 0 is shift to this location. This 0 is shift to this location, and this one is shift to this location 1. Okay. So you can see that it is shifting here. No, it is shifting here. Okay. So try to do this for 1 also by yourself. Okay. Then you can understand what happened. Okay. So I hope it is very clear and it is not much difficult. Okay. So I think you can understand how a register is operating. Okay. How a shift register is operating. Okay. So you can see that it is shifting the bits. Okay. It is shifting the bits, available bits. Okay. So I hope you can do this for the 8-bit also, 8-bit flip-flops also. I think it is easy. Okay. So in our reference book, okay, we have this flip-flops. Okay. We have this flip-flop. Sorry, we have this register. That is this one. Body counter. Is that I think I saw it. Okay, I saw actually. It is in the okay. These are the shift register 11.12. Okay. Okay, so this is serial in, serial out shift register. Okay, so these are the 4 shift register configuration based on the input and output way. Okay. Okay. So this is a flip-flops. Okay, this is a CISO shift register made up with the flip-flops. Okay, the operation is same. Okay, you can see that. Okay. And here the timing waveforms are drawn. I think now you should be able to draw this timing waveform also. Okay, by yourself. We have draw this timing waveform for counters. Okay, the same way you can draw the timing waveform. You should be able to draw the timing waveform for this serial in and serial output register. Okay, so try to do this by yourself, and if you have any problem you can ask me. Okay, but for the exam I will not give the question with the D-type flip-flops. Okay. Okay, I will restricted my question only for SR and JK flip-flops. Okay, and mostly edge-triggered flip-flops. Okay, JK or SR edge-triggered flip-flops. Okay, So my question, the exam question will be mostly based on that type of flip-flops, okay? Not D flip-flops or this clear status flip-flops, okay? Okay, but I think you better, okay, for you understanding, if you do this by yourself, I think it will be better, okay? So if you have any question, you can ask me, okay? Please do this and ask, okay? Okay. Yeah, this one, no? Okay, so this is how many flip-flops? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that is 8. Okay, that is 8-bit. Yeah, you can see that this one. Okay, so we have this shift register in our laboratory, okay, and you can use that one and you can see what happened. Okay. Okay. Yeah. Okay. So this is the shift register. No? So you can see that the clock pulse is given simultaneously. Okay. And this is another flip-flops. Okay. So I hope now you can understand the operation of this flip-flops. Okay. This register, this shift register. Okay. We have talked about this register. Okay. But we have seen up to 4 flip-flops, okay, but it is very easy. You can go for 8 flip-flops also, okay. So try to do this by yourself, okay. And okay, so also try by yourself, okay. No, I think that is enough, okay. So try to draw this waveform by yourself, okay, this timing waveforms by yourself, okay, and try to understand the operation of the flip-flops again, okay. Then you can move to this one and you can no need to draw the timing waveform here, okay. Just try to find the status, okay. When the input is available, try to find the status, okay. Okay, so we will stop here, okay. And I think we have also learned about the register now, okay, shift register, okay. So I think now we can move to the LO2, okay. So next week we will go to the LO2, our learning outcome 2. But after doing LO2, okay, I hope again to do some thing, to study something more about register, okay, because we just see the introduction here, okay. We just see the basic operation here, but I think it is not enough for your level, okay. We need to go somewhat deeper, okay. So we will do that one after the LO2, okay. If we have time, we will do that one, okay. Okay, so thank you very much, okay. So I will stop sharing.